Hello guys, welcome to MoBileMaThS with Try. Today we want to look at vectors too. Okay, so I'll start with magnitude. We want to look and calculate our magnitude. So when we talk of a magnitude, we talk of size. It's the same as size of a vector. Okay, so this can be represented by the length of the line segment. I can have an example here. I've got line AB. So the length that I'm talking about is from here, from A to B. That's the size that we are talking about, or the magnitude that we are talking about, that we want to find from point A to point B. Okay, so if we want to find, I can write, for example, our AB there as a vector, AB. So we have an arrow there to show that it's coming from A to B. AB, the vector is, we are moving 4 points on the x-axis, 4 and minus 3 down there. So I've got 4 minus 3. Okay, so always remember that when we write our vector, the first one is x direction and y is the second one. Okay, now for us to find the magnitude, we have a formula. To find the magnitude, remember we had our A, B, this denotes that it's a vector. So if we want to find the magnitude, we use these signs, A, B. Okay, so this is the magnitude of AB. And we have a formula. Remember, we talked about x and y. So at the end of the day, our formula for magnitude is x squared plus y squared. And always remember that the modulus, these signs here, these denote modulus. Okay, and our modulus is always positive. It's always positive. Always remember that. So now, taking into consideration our AB, which was 4 minus 3, let's put it into our formula and see what we get. We will get our modulus of AB as square root of 4 squared plus minus 3 squared. I'm putting so that you see it's a negative there. Now we can now simplify. The modulus of AB is equal to square root of 4 squared, we get 16, minus 3 squared, we get 9. Okay, so at the end of the day, we have square root of 25. Square root of 25, we get a 5. Okay, so the modulus of AB, or the magnitude of AB, is 5 units. Okay, so that's the first method that we use. Let me go back and see if I can show you from my diagram. It's not that clear, so I will show you in the next video. Okay, let's look at scalar. Okay, let's look at scalar. Scalar, remember we talked about a vector, and we said when you have a vector has got direction and magnitude. Okay, always remember that. And we have calculated the magnitude. Now we want to introduce scalars. The same way we do in matrices is the same way that we do with vectors. Let's say if a vector AB is multiplied by a scalar, is multiplied by a scalar K. Okay, we say any number. Our k can be any number. It can be -2, can be +3, can be a fraction, and so on. We say the result of our AB by the scalar will be k times AB. Let me show you what I mean. Okay, let's say we have our AB, the same that we used in the magnitude. Our AB as 4 minus 3, and we want to find, we have a scalar. Our scalar is -3. We want to find, what do we get? Okay, so what we do here is this. We come and say 3AB, meaning to say we are multiplying with our scalar, is equal to 3, sorry, it's minus there, minus. Then we multiply by our vector AB. Okay, like that. Now I come -3 by 4 minus 3 there. Okay, then we multiply each item inside the scalar with inside the vector with -3. Okay, so I'll have -3 times 4, I get -12. Okay, -3 times -3, I get a 9. It becomes a positive. So this is -3 AB. This is the solution that we get for that scalar. Okay, let me have another example where we have a fraction. Let's say we've got a fraction. So I have got 1/3 AB. We want to find that. We'll simply do the same. We'll have our 1/3 by our vector 4 minus 3. Okay, like that. So we are going to multiply each item with 1/3 there. So for the first item, I'll have 4/3. The next one, -3 divided by 1/3, I'll get a -1. So this becomes the solution of AB with the scalar 1/3 there. So this is how you do when you have a scalar. Otherwise, have a good day, guys. Bye-bye.